Hello, good morning, good afternoon, good evening to all of you around the world, Clemson University, Netherlands, everybody joining around the world. This is exciting. It's very nice to see you all. My name is Dil Thavaraja. I am a professor here at the Clemson University, overseeing the pulse quality and the nutritional breeding program. And we host the Going Organic webinar series every month from fall to spring. And this seminar series is funded by the USDA, National Institute of Food and Agriculture, NIFA OREI, and South Carolina Department of Agriculture, USAID, Feed the Future Innovation Lab, the Good Food Institute, and the USDA ARS, Agriculture Research Services. I am so happy to introduce today's speaker, one of my friend and Dr. Hannah Van Zanten. She is one of the recipient of the Global Food Short Prize from the Global Food Short Institute. Dr. Hannah Van Zanten is a visiting professor in the Department of Global Development at the Cornell University. She is also an associate professor at the Washington University Farming System Ecology Group and the project leader of the Circular Food System Project. And she is really like to unravel how a circular food system can contribute to increase in the human health as well as the healthy food system to provide the great food for the world. And her information regarding the fascinating about this food system, how we're going to shapen it up to reduce all these health issues related to food. So she is one of our co-workers to work with this global idea of shaping the food system. With not taking much more time, I want Dr. Zanten to take over, and thank you so much for coming today.
So much for the introduction. So I'm Hannah van Zanten. I'm associate professor and interim chairholder at the Farming Systems Ecology Group at Wageningen University and visiting professor at Cornell University. We all know that the food system has a large impact on the environment and especially the livestock sector. And because of that, we are often looking for potential solutions. And one solution is to, for example, consume a vegan diet. But it is good to note that those solutions are often locked in with our current linear food system. So what do I mean with that? So if we perform an environmental assessment, such as a life cycle assessment, we often assess today's food system or a chain, such as a dairy sector. So we kind of take a picture of how the food system looks today. And from there, we actually start to look for potential solutions. So our solutions are already based on the food system that we have today. We can also think more outside the box and try to redesign today's food system. And that's what I'm doing with my team, the Circular Food Systems team. And we are looking for potentials to redesign today's food system based on circularity principles that will help us to feed a growing population with healthy food while respecting the boundaries of our planet. So redesigns, as you can see here in this picture, are based on circularity principles and per default need to respect the planetary boundaries and make sure that we produce enough healthy foods. So during the next slide, I will explain you those circularity principles in more detail. So the first circularity principle is to make sure that we stay within the planetary boundaries. And we can do this, we have to think of many aspects while thinking of respecting the planetary boundaries. So for example, fishing at a sustainable level, at an equilibrium, halting the use of finite resources, restoring soil and carbon stocks, and enhancing biodiversity. And there's much more that we have to consider, but those are just some examples I wanted to share with you. So the second principle relates to making sure that we use biomass for our basic human needs. And today we use a lot of biomass to actually produce things that we do not really need. So what are things that we really need? For example, producing healthy food. That's something we really need. But we also need fuels for cooking, for example, or fiber for make our clothes to keep us warm. So those are basic needs, and that's one of the things that we have to prioritize the use of biomass for. Then the third principle relates to avoiding waste. And waste can be something such as food waste, so everything that we spill, but it is also overconsumption, because if we consume too much, we actually take or use nutrients that we do not really need. And another kind of waste are also potential byproducts that then don't have a function or are less utilized. So, for example, if we produce bread, we can use bread or produce bread on refined grains or on whole grains. So, if we use whole grains, that's actually more healthy for us and from an environmental point of view better, because on the moment we are using those byproducts for other purposes, it also often loses efficiency from an environmental point of view. So if we cannot avoid waste, we should use the waste in the most efficient way. So think about making sure that crop residues are staying on the field, using our own human excreta as a fertilizer, or feeding those leftover streams, such as, for example, crop residues or food waste, to our animals. And they can utilize it again and produce animal source food that then contributes to our diet again. And the last circularity principle relates to making sure that we use renewable energy, but also make use of new technology. So often when I talk with people about circular food systems, they think we go back in time. But we can also really make in a circular food system, we can make use of those new technologies. So using sustainable energy sources is really crucial in this. But also if we don't, like if we have waste, then we can use this waste, for example, as feed for insects, or for example, manure can be used as a feed for insects. So there are all those kind of potential options that are not so explored much, which we can integrate in new redesigns of the food system. So to show you that this is not only a concept, but that this is also something which is actually happening in reality, I would like to show you this little video of where I'm visiting a farm. So the farm is called Kipster, and Kipster is a laying hen farm in the Netherlands, and they actually also now they also just opened the doors in the US. And Kipster is only feeding leftover streams to their laying hens. And they get the leftover streams from a company which is called Nijs en Granico. So in this little video, you see the company which is collecting the waste and the laying hen farm here in the Netherlands.
Een circulair voedselsysteem is een systeem waar we in de toekomst naartoe willen, om ervoor te zorgen dat we voldoende voedsel kunnen blijven produceren binnen de grenzen van onze planeet. Waarbij we dus bijvoorbeeld zo min mogelijk land willen gebruiken of zo min mogelijk water. Zodat we de aarde niet uitputten, terwijl iedereen wel beschikking heeft tot voldoende voedsel. Ik ben Hanne van Zanten en ik onderzoek de rol van het dier in een circulair voedselsysteem. De rol van dieren in het circulair voedselsysteem is dat ze eigenlijk reststromen kunnen eten. Dit bedrijf hier verzamelen ze die reststromen en daar gaan ze uiteindelijk weer veevoer van maken. Ja, dat zijn producten die anders weggegooid zouden worden. Het zijn producten die we niet kunnen of willen eten. Wat we op dit moment ook zien is dat dieren met producten worden gevoerd, zoals granen, die wij ook kunnen eten. En daardoor ontstaat er eigenlijk een beetje een competitie om die granen, of we die nou aan dieren gaan geven of aan de mens. Al die producten komen binnen in de fabriek en een heel proces komt eraan te pas en uiteindelijk hebben we een brokje. Bij Kipster hebben we gekeken met hun overlegd van nou, wat voor een voer zouden die kippen nou eigenlijk moeten hebben om toch ervoor te zorgen dat ze die eieren nog kunnen leggen, maar wel een voer wat dus alleen maar bestaat uit restproducten. Want ieder dier heeft natuurlijk zijn eigen unieke eigenschappen En wat ik wil weten is welk dier we nou het beste kunnen gebruiken om welk restproduct uiteindelijk om te zetten naar bijvoorbeeld melk of vlees of eieren. Die hoeveelheid aan reststromen die we hebben is natuurlijk beperkt, beschikbaar. Dat betekent ook dat er een grens zit aan de hoeveelheid dierlijke producten die we kunnen produceren. En op dit moment zien we, als we dus naar zo'n circulair voedselsysteem toe zouden willen, dat we in Europa de hoeveelheid dierlijk product wat we nu eten tenminste moeten halveren. Ik vind het heel leuk om dat te zien, dat het in de praktijk daadwerkelijk een bedrijf is wat dit oppakt en wat gewoon alleen maar reststromen aan zijn dieren voert. Omdat dat aangeeft dat we dus langzaam echt naar zo'n circulair voedselsysteem toe moeten. Het is niet alleen een theoretisch iets wat nu ontwikkeld is, maar het is ook iets wat nu door de praktijk wordt opgepakt.
So I hope this video illustrates or shows you that there are companies that are really picking up those different circularity principles. So what I would like to show you in the next couple of slides is this potential role of animals in circular food systems. Because now in a previous slide, I explained to you what those circularity principles are, but I didn't show you what the potential is if we would really assess them. So first I will really zoom in more on the role of animals in such a circular food system. So if we would only feed animals with the leftover products from our food system plus the grass, so we are talking here about byproducts, we are talking about the food waste and the grass products. If we would feed those different streams to our livestock, we can produce between 9 and 23 grams of protein per person per day. And we need around 60 grams of protein per person per day. Although there's some discussion about this, and of course it depends on your gender, on how active you are, your age, and so on, but just keep the 60 grams of protein per person per day in mind. Then you can see that we can get around between 9 and 20 grams of protein per person per day by only feeding the animals with leftover streams. So if we would consume a vegan diet, we would need to replace those animal proteins with plant-based proteins. And those plant-based proteins do require arable land. And that brings me to this next figure. So what you can see here in this figure is the amount of grams of protein from animal source food in a certain diet. And you can see the amount of arable land used for a certain diet. And it's important to realize that we are talking here about arable land, so not agricultural land, because agricultural land includes arable land plus the grassland. So this is only related to the amount of arable land that is needed. And then you can see the 3 different types of diet. You can see the circular diet. So in the circular diet, the animals are only fed with leftover streams. And you can see here the vegan diet and our current diet. So what you can see is that the circular diet uses less arable land compared to the vegan diet, and it uses much less arable land compared to our current diet. We did a similar assessment, but while the previous one was focusing on the global scale, this one focuses on Europe. And what we did here is we looked at the amount of greenhouse gas emissions that are produced for a certain diet. And we looked again at the amount of animal source foods, the proteins from animal source food in a certain diet. And here we took the Eat Lancet study as a reference point. So what we did is we looked at the amount of plant-based products that are recommended in the Eat Lancet reference diet. And from there, we started calculating the amount of leftovers. So the amount of potential food waste, the amount of byproducts that are produced when we are consuming that part of the plant-based part of the Eat Lancet diet. So that amount of leftovers that we calculated, we wanted to use in the most optimal way to produce animal source food. And the animal source food then needs to fulfill the recommended amount, which was recommended by the Eat Lancet publication. So the recommended amount of animal source food in the Eat Lancet reference diet. And then you can see here 3 different scenarios. The first one is a healthy, completely healthy scenario, the blue scenario. So this scenario is completely in line with the recommended amount of animal source food in the Eat Lancet reference diet. Then you have the orange scenario, which is slightly less healthy because here we allowed food to be processed. So people were, for example, consuming refined grains instead of whole grains. So this shows the impact of processing in the food system, in a circular food system. And then in the last scenario, the only circular scenario, which is the black one, we didn't consider any health recommendations by the Eat Lancet, but we just tried to optimize the amount of animal source food. So from that amount of leftovers that we got, we tried to produce as much animal source food as possible. So then you see the dot on the Eat Lancet itself. It was the scenario from the Eat Lancet, and you see this red line, which indicates the amount of greenhouse gas emissions roughly for a diet. So that's the amount of greenhouse gas emissions that we have available if we want to stay within the boundary which was recommended by the Eat Lancet publication. So what does this show us? It shows us that all 3 scenarios are circular, but the amount of animal source food really differs. You see that if we consume a whole healthy diet, we have less animal source food, but we also immediately reduce greenhouse gas emissions. Well, if we go to the other opposite, to the only circular one, we actually consume too much red meat, and that red meat is coming as a byproduct from dairy sector because the dairy cows are really efficient in recycling all those products. So they consume the grass plus all the byproducts. But if we produce dairy, we also have veal calves and we also have the slaughtered dairy cattle. So that results in a lot of red meat. So in principle, we see that in that only circular scenario, the amount of red meat is exceeding the recommendations. So this shows us that circularity not necessarily goes hand in hand with a healthy diet and that we need to consider this complexity of the food system. So in general, the results that we found really showed that upcycling or using animals kind of as an upcycler, so to recycle the leftovers that we have in the food system, is a no regret solution. But their role really depends on how we redesign the food system. So do we consume, for example, a healthy diet, or do we keep consuming today's consumption pattern, today's diet? Those things all have an impact at the end on the role of animals in a circular food system. So to better understand the connections within the food system, we started developing the circular food systems model, the CFOS model. And what this model does is it minimizes a certain environmental impact in terms of, for example, land use and greenhouse gas emissions. And we now have the model ready for Europe. And probably the publication on the whole model, which gives a lot of model results, will be published in April in the Nature Foods. So if you're interested in this, please feel free to send me an email, and I'm happy to forward you the publication. So what the model does is it's ready for Europe and it minimizes the environmental impact in terms of land use and greenhouse gas emissions. But we are also extending it towards a global model, and we want to assess, besides greenhouse gas emissions and land use, also NP, water use, and biodiversity. So in the model, we have the constraint that we want to produce a healthy diet. And with a healthy diet, I mean that we produce the nutrients that we need on a daily basis. So for example, enough protein, enough vitamin B12, enough calcium, and so on. But not only the nutrients, we also want to make sure that we consume the right foods. So for example, not too much sugar, not too much processed red meat, and enough fibers. So those are all constraints in the model. Then we divided Europe into around 8,000 different zones. And in each little zone, those little zones were based on climate and soil conditions. So based on those climate and soil conditions, we could say which crops we could potentially grow on that little zone. So if the model selects a certain crop it creates also crop residues, but it also creates byproducts. And of course, it creates human food. So from this human food, part of it might be wasted. We will definitely also produce human excreta. And those different leftover streams can partly be used as a fertilizer for our crops or the grasslands, or it can be used as an animal feed. If we use it as an animal feed, then the model can produce animal source food, which contributes again to our diet requirements, but it also creates certain leftover streams. Think about, for example, slaughter waste or manure, which can also be used. Besides feeding the animals with, for example, food waste or byproducts, we can also feed the animals with the grass, and we can produce also byproducts from the fisheries. So from the fisheries, most of it goes to human consumption directly, but again, the byproducts can be recycled by, for example, the animals. So at the end, the model tells us which crops to grow where, how to fertilize those crops. Should we use, for example, artificial fertilizer, food waste, human excreta, animal manure? So are the best types of fertilizers to minimize the environmental impact? Which animals should we keep? How productive should those animals be? And how many and where to keep them? And last, what should we consume to have a healthy diet that respects also the planetary boundaries? So of course we can add as many constraints as possible. What we aim to do with the model is to provide this dot on the horizon. How could this circular food system potentially look like? But at the same time, we can also add constraints and come closer to reality. Of course, we have a baseline in the model, so that represents today's situation. But going from this baseline to this dot on the horizon, and by adding all kind of additional conditions based on socioeconomic factors, we can start to create transition pathways. And that's where we are interested in to show the potential of redesigning the food system and how we can actually come there. So over the last years, we developed this circular food system model, and here I want to show you the very first results. So if we redesign the European food system towards a circular food system, we can reduce agricultural land with around a third, and greenhouse gas emissions can be reduced with around 50%. This requires both production and consumption changes. So let me start first with the consumption changes that are needed. Today's protein supply is around 103 grams of protein per person per day. And this will be reduced to around 82 grams of protein per person per day. And this reduction largely comes from animal source foods. We do see an increase in vegetables and legumes. What is important to know is that the 82 grams of protein per person per day is supply, so that's not actual intake. So part of this might be wasted. So here you can see the difference between the current diet and our potential circular healthy diet. And you see large reductions in proteins, and this mainly comes from the animal source foods. Besides those changes in consumption pattern, we also need to redesign the production sector. And this means that we need to change both crop production systems and animal production systems. What we saw is that agricultural land is largely reduced, and this reduction mainly comes from grasslands. And this potentially provides the option to enhance biodiversity. Well, we saw that that arable land largely remains in use. But we saw that different crops were actually selected. So less grains and more legumes, vegetables, fruits, and beans, for example. So a more diverse cropping system. We also saw a large redesign of the livestock sector. In fact, animal numbers largely decreased. And this reduction mainly came from, or actually we saw a large increase in the fish sector, and most of the other animals numbers decreased. But we still saw that the animals are essential in providing some of the essential nutrients. So I realized that this redesign is rather radical. But it is important to realize that all those changes that I just mentioned to you, they don't require new technology. They can actually be implemented on a relatively short term if people will be willing to do so. Because they are based on a transition towards sustainable energy use, consuming a healthy diet, avoid the waste that we have in our system, use human excrete and all other residues or leftovers that we have available, and go to a more diverse cropping system. So, all things that we can do today. So, my take home message is that redesigning this food system towards a circular food system offers the potential to respect the planetary boundaries while producing healthy foods. This, however, requires both production and consumption changes at the same time. So we should be aware that we need to focus on those together. And it requires a food systems approach to build those redesigns of the food system, to understand the complexity of the food system, as often potential trade offs can happen, as I showed you in this one figure in relation to health and circularity. So it's important to embrace this complexity to actually really understand what is needed to come to a sustainable food system. Thank you so much for your attention. Are there any questions?
This is wonderful, and it's complicated, and but it's amazing. Thank you so much, Hannah. We have lots of questions, so I do have questions too. So let's see what, yeah, people trying to send questions on the question and um, answer. I want to start with the broader question. So you're kind of suggesting that we should have less intake of all this food. Like, for example, protein is like 100 grams that, and then with your approach is like 82 grams of protein in a diet. What kind of problems you running into when you suggest that kind of thing to the society, like the culturally, like I am trying to impose on pulse-based diet. So what kind of cultural issues you running into like in your country, and then I also want to talk about how we can take this approach outside the Netherlands, like to the Europe and
Yeah,
US.
yeah. So the results that I showed were on a European basis, but we don't have the US yet. So that would be great. Um, so yeah, I think what I found very interesting is that if I present this, most of the time people are interested in a sustainable transition. So in that sense, I think I most of the time have an audience that are already thinking of changing their diet. So I think the reduction in animal source food, that's at least if I present, if I give a presentation, it's most of the time people know. That doesn't mean that they want to change, but they know. But then they see that little glass of wine disappearing. And then it becomes extremely tricky because they didn't think about the wine yet. So I think it's not only, like over the years, there were a lot of scientists that said, like, okay, we need to transition to a more plant-based diet, but then also considering the wine, that sometimes goes a step too far. Of course, then if I had a little video for a more general audience, and then you see the responses, and yeah, I think then we still have a very, very long way to go to get to that to get to a more plant-based diet. So I definitely think it takes a lot of effort.
I
Yeah,
totally agree with you because your food system, I have been following this for a long time, how we can approach that into like US, because our grain farmers are a big deal, and then our animal plant um, animal production also are a big industry. So I don't know what's your thought on how do we balance less grain, less animal product. How do we balance this in a country like United States?
yeah, yeah. So we indeed also have a lot of grains in Europe and a lot of livestock. I think it's also, of course, what I aim to do is to create that model. And what I feel is that if we can come up with 1,000 potential redesigns, and no one will feel the ownership, like, yeah, this is what we need to do, because they didn't design it themselves. So what I hope, what we are trying to do in the next steps, is to actually translate the model into a kind of game. And that game then allows policymakers, but also different, like the industry, like different stakeholders, to co-design the food system with that game. So they get more insight of what are actually the consequences of having those high livestock numbers and having those, a lot of grain fields and so on. And I hope that if it becomes more in co-creation, we get more awareness, and then we might make steps. But I feel that as a scientist, and me just publishing my work is not so effective. I feel I need to do much more to get this ball rolling of getting this transition there. But of course, I think if it starts with this awareness, but then and the need to actually get to that change. And I hope and I think we scientists can really contribute to creating that awareness.
I think so too. I really think so. And also, when you design your food system, would you actually link the occurrence of diseases?
Yeah, so I didn't do that yet, because what we have, and I have a super long wish list of things I want to add, but yeah, I mean, maybe in time that, we just take it step by step. But because a lot of people indeed assume, like, also that a circular food system will improve animal welfare, for example. But I don't think that's per default the case, because that really relates to how we design the farming systems. And you can still, say that in a circular food system, we have huge farms that are, from a disease point of view, but also from an animal welfare point of view, still have high risk. So I think with designing the food system, we also need to zoom in then on the farm level and to see, okay, how are we distributing those animals in such a way in those areas, because we have the animal numbers now on a zone level, but from that zone you need to start distributing them in a way that you really improve animal welfare, but also reduce the risk for diseases. So
This
this is a next level. Yeah.
this is amazing. You got a lot of questions. So let's move to the audience because I have lots of questions to ask. This is a question from Dr. Hilda. She is from Rwanda. And her comments is there are advantages of consuming animal source food as they contain some unique nutrients. Hence, they should not be eliminated in the production system. So, what's your thoughts on that?
Yeah. So indeed, they should not be eliminated from the food system. That's also what we see. So we in the model that we have the whole range of nutrients in it. So like the protein, calcium, vitamin B12, like the fatty acids, all the essential things that we need to consider. And what we see is then if we minimize greenhouse gas emissions and land use, you do always see that there is this role for animals in it. So in terms of like for high income countries, this means a super large reduction in the amount of animal source food. But for low income countries, that we see also an increase in consumption. So it really depends on where you are. And of course, because of those problems are so much focused on high income countries where this overconsumption take place, I automatically focus on that more in my work. But we are now also with a PhD student looking in designing a circular food system in Ethiopia. And that will give us complete new insights. So the amount is dependent, or how the amount is changing is really dependent on where you are. But that animals provide those essential nutrients, yes, they do. But we don't need to consume as much as we do today in higher income countries.
I agree with you. And then I don't think, if I understood correctly, you're not saying not to eat meat. You're just asking them to eat less meat and introduce more other diversity into your diet. Kind of,
Exactly.
yeah.
Yeah.
So that
And then have the meat from animals that are raised in circular systems.
Exactly. So I have a different project with you. We'll talk about that later. So let's see the next question. This is from Dr. Tava. He's asking, what is the role of legumes and pulses on this circular system? Basically, the crop that we breed in my program, we breed peas, lentils, and chickpeas, and these are the three major crops, and it's organic. And actually, what is the role? So this is where our collaboration starts.
Yeah, great, thanks. So we have 50 crops, including legumes, in the model. What we do see is that if you reduce your amount, if you reduce your amount of animal source food, legumes start to play a bigger role. But it becomes more difficult on the moment that you really start to force a diet which goes into the really recommended amount of protein, because then you are so low in your protein, and then you still need to fulfill all those other nutrients, and then you actually need products. Then the role of animal products become more important, although they are still largely reduced because you eat so less, so it's so much less that you consume in that recommended amount. But then that combination, that profile of nutrients together becomes so tight that it needs the animal products. So this is really interesting. Well, if you consume today's diet with much more proteins, you can go largely really go in this direction of a vegan diet, and then the pulses play a big role. So I think that also shows again the complexity of and where you are. So I think this increase in pulses is especially essential in high income countries where we tend to consume more than we actually need. So
like our country is like going to be most probably 50% obesity in near future in the global population. So Europe is not that high compared to American data. So you're correct. And we have a lot of work to do. And there's another question from one of our economists, Dr. Dave Lemaine, and he is saying, I hope to be in Europe this fall. He always go to Europe on sabbatical working on agrotourism, sustainable food system. And I would like to put in touch with you. So he wanted
of course, you're very, very welcome. Yeah. And I put on but I can also put in the chat my email. So then everyone, also
yeah,
with additional questions, feel free to contact me.
yes. So, okay, there's another question from Hilda, Dr. Hilda. In circular food system, there are 10 R's. For redesigning animal source food, which R are you suggesting that can be targeted?
Can you repeat that one? Sorry.
So she's saying in circular food system, there are 10 R's.
10 R's.
Yeah, I don't know what
Okay.
that. And for redesigning animal source food, she's asking probably reason, that's what she mean, are 10 reasons. And then which reason are you suggesting that can be targeted to reduce the animal source food?
So from this from the different R's in the circular food system, from the 10.
Right.
I don't know if I know all 10.
Yeah,
So,
exactly. It's very popular.
yeah. So and how what is so why do we, if we redesign it, do we need to get to reduction in animal numbers? So I think so the main reason why we need to come to reduction in animal numbers is
Yes.
that today we feed the animals with a lot of products that we can consume ourselves too. So that means that therefore, because of that feed food competition, that has an impact on food security, but it also directly have an impact on the environment. Well, if we feed them only with waste, and then you come into one of the R's, so use the animals as recyclers, then you avoid this feed food competition. Therefore, you improve food security and you decrease the environmental impact. So I see that as offering the potential. So animals in the circular food systems offer the potentials to have them as a kind of recyclers in the system. But that does require us to reduce the numbers.
Yeah, that makes sense. And there's a successful story shared by Carl DuPault I think he's from North Pennsylvania. So he put a nice note about Gabe Brown came to regenerative agriculture through hardship. In 1991, as in-laws retired and he took over their 1,700-acre farm outside Bismarck. Bismarck is in North Dakota. It's a very cold area, and there's a lot of grain growers in there, large grain growers. These are not small growers, very large growers. And Carl is saying he used the same practices they had used since 1950s: tillage, fertilizers, pesticides, and fungicides, as well as the conventional grazing practices. So I think your concept is wonderful. What he's kind of appreciating you're doing is like, and then people were thinking about it this in 1950s, and if you wanted to comment anything, and he put a link as well about this family in
Okay, yeah.
Yeah.
Yeah, so I completely agree that a lot of those things we were doing earlier, and I think as we were also not, if you look at the consumption trends, we were never eating so much as we do today. So I think a lot of those things are indeed much more, let's say, much better from that perspective. Of course, there were other problems. And that's why I also put that fifth principle there, that we shouldn't say that we should not make use of new technologies, because a lot of people think, oh, with circularity, we go back in time. But I don't think we go back in time, but we do in certain aspects indeed go back in time, but we still can make use of the new aspects that we developed over time, and that also helped us over time as well. So it's getting more appreciating what we have, I think, is a good start.
So Hannah, you work with the social scientists hand in hand, or how's that work in your work? Like,
No, not too much. We just started doing that. So I now have there are two PhDs that are working together in one project. So, and one of them is doing the modeling, and the other one is doing the social aspects. And what they, by really having this integrated PhDs, they want to understand the social economic conditions better. So this is, and we do that for different case countries. So this is our first step. So previously, all the PhDs just worked on hardcore coding, and that's still what most of them are doing. But here we are making this first step towards actually working with social sciences, and we are developing this game now, and based on serious gaming principles. So we are going more into the direction, but it took us so much time to build this huge model, so we were not there yet before.
that is a very nice concept, gaming.
Yeah, I think so too. It's very powerful.
It's very powerful to change the system into like people never thought about it. So on behalf of the Clemson University and on behalf of my program, Pulse Quality and Nutritional Breeding, and I am really thankful that you brought this most important discussion about the food system and put this into people's head and think about it, because this is something, that's why I also really like to work with you on the how we can bring these traditional pulses into the diet. Some people, they eat it, but we want most people to eat it. So then we can link to reduction of malnutrition and obesity. So I think your work is amazing, and I hope to be contact with you and start some work on different projects. And thank you so much to joining our webinar today. So next week we have another exciting seminar, and it's our last seminar for the Growing Organic System. And unfortunately, I will not be the host. The host will be Dr. Nathan Johnson, and he is one of the research fellows in my program. And the next month talk would be April 19, 2023 by Dr. Jeff Rumney. Dr. Jeff Rumney is the marketing director at the USA Dry Pea Lentil Council, and he will be talking about how we can market pulse crops, especially lentils, peas, and chickpeas. So that will end our webinar series for this spring, like bringing all these wonderful speakers around the globe to a one place and we talk about how to shape our food system in a different angles. Thank you, Hannah, and thank you everyone for coming. And we will see you again on April 19th. Bye, Hannah. Thank you so much.
Thank you so much. Really great. Thank you.
Bye.